안녕하세요. 한국인들과 카르다노를 이어준 다리 코리아풀입니다. 바질 하드포크가 완료되고 카르다노의 확장성을 위한 플루터스 버전 2, 확산형 파이프라인인과 같은 기술이 사용되고 있습니다. 오늘은 찰스의 통찰력을 빌려 카르다노의 확장성을 위해 앞으로 어떤 로드맵이 준비되고 있고 어떤 기술이 개발되고 있는지 알아보도록 하겠습니다. 먼저 찰스가 설명하는 카르다노의 현 시점에 대해 알아보겠습니다.
So there are two eras left for Cardano. There's Voltaire and Basho. Okay. And they're being done concurrently. So like all things, we try to make things run as quickly as possible. And the Basho team is very different than the Voltaire team. So the Voltaire team is all about governance, and there's an enormous amount of progress that's under the hood. And this is things like the members-based organization, a constitution. There's lots of SIPs that are currently being drafted and soon to be announced. And we'll have a lot to say in November about all of this. It'll drip its way out. So not too long, and that's going to be at the Cardano Summit. But let's talk a little bit about Basho. So Basho has a lot of stuff in it. So there was diffusion pipelining was an example. And this is a spectrum. So we launched version 1. But there's all kinds of optimizations that can be done there. And this came with Vossel. We've already seen a huge impact. There are improvements to Plutus. So version 2 is already out. And next year, there'll probably be some sort of version 3. And we've already seen a huge impact. Some people say a 10x reduction in script size. And all kinds of things. So lots of cool stuff there. These are known things, and we've already seen some of these things come out in Vossel. So we're actually already starting the Basho era. We're in it right now.
찰스는 최근에 멤버 기반 조직, 다중 언어 생태계 등등 가버넌스에 대한 프로젝트를 자주 언급했습니다. 11월에 있을 카르다노 서밋에서 멤버 기반 조직에 대해 더 자세하게 발표한다고 하니 카르다노의 탈중앙화 방향성에 대해 더 들어볼 수 있는 기회가 될 것 같습니다. 그리고 현재 진행 중인 바쇼 시대에서 우리가 기대할 수 있는 여러 프로젝트에 대해서도 자세하게 설명했습니다. 여러 프로젝트에 대해 알아보기 전에 잠시 바쇼 시대가 추구하는 확장성의 방향성에 대해 잠시 설명하겠습니다. 바쇼 시대의 목표는 많은 일을 단 한 번의 작업으로 축약함으로써 전체적인 성능을 개선하는 것입니다. 블록체인 블록 기록을 하나하나 검증하지 않고 모든 블록 기록을 단 한 번에 검증할 수 있다든지 수천 번의 거래 내역을 하나의 거래 내역으로 기록하는 것과 같이 단 한 번의 작업으로 수많은 일을 처리할 수 있게 됩니다. 우리가 흔히 말하는 TPS는 확장성을 측정하는 단위이며 1초의 트랜잭션이 얼마나 빠르게 검증되고 기록되는지 측정합니다. 다만 명확히 짚고 넘어가야 하는 것은 TPS가 측정하는 트랜잭션의 기준입니다. 예를 들어서 1초에 1개 트랜잭션이 처리되는 블록체인 A와 1초에 10개의 트랜잭션이 처리되는 블록체인 B가 있습니다. 단순히 TPS 숫자로만 보면 블록체인 B가 더 빠른 것 같습니다. 하지만 100명에게 암호화폐를 보낼 때 블록체인 A에서는 하나의 트랜잭션으로 할 수 있는 반면에 블록체인 B에서는 100개의 트랜잭션이 필요하다면 과연 블록체인 B가 더 빠른 것일까요? 찰스도 이에 대해서 짚고 넘어갑니다. 효율성으로 봤을 때 블록체인 A는 100TPS인 것이고 블록체인 B는 10TPS인 것입니다. 그래서 이렇게 여러 개의 트랜잭션을 하나의 트랜잭션을 묶어버리는 여러 프로젝트가 진행되고 있고 먼저 바쇼 시대에서 다양한 곳에 활용될 매우 중요한 기술인 미스릴에 대해 알아보겠습니다.
But then there's some things that are on the horizon. So there's Mithril, for example, and Mithril is rapidly approaching version 1. Whether that happens this year or not remains to be seen about the development velocity, but SPOs are already testing it. We already have a pretty nice open source project materializing, pretty good documentation. And there's a lot of open questions of, well, what does Mithril do for scalability? Now, if you're on cryptocurrency Reddit, they say absolutely nothing and it achieves nothing and it's just all made up marketing speak. And that's because they're idiots. So we won't pay much attention to them. The reality is that Mithril is one of the biggest pillars of Basho. So what Mithril does in a nutshell is that you have your layer 1, so this is Cardano, and really what it's doing is it's creating this kind of this overlay and layer 1.x-ish. And that overlay basically gives you the ability to construct proof certificates. And that's a super useful capability. Like, for example, when we think about SIPs for on-chain governance, just as an example. Now, the naive way would be that everybody votes. Okay, well, that's fine. But what happens when you have 3 million votes occurring for each thing? Wouldn't it be really cool instead to construct all of that off-chain in a network and then just aggregate it together as a threshold signature and have a single transaction occur on-chain? And that has the same impact and the same trust assumption as if you've aggregated all 3 million of those. Well, that's effectively what Mithril does. And the special case of Mithril right now is for light clients and for fast bootstrap. Okay. So basically bootstrapping a full node quickly and then giving light clients full node security, even though they are a light client. Well, this is a framework, and it's a networking framework and a proof construction framework and a commit framework to get it onto the Cardano main chain. And that framework is basically going to allow many to one or some. Part of scalability is saying, well, hey, we want to do lots of stuff in just one thing. If you kind of think about what's happening with version 2 of Plutus, it's doing the same thing with reference inputs and reference scripts and inline datums and these types of things. It allows you to basically have reusability. It allows you to compress a lot of things that are happening. So you're going from many to one. So instead of doing something in 500 transactions, you do it one transaction, and it's just constructed a little differently. The nice part about Mithril is it's moving very quickly. And the nice part about Q4 to Q1, this time horizon, is that we get this fast bootstrap and light client application, but we intend on using Mithril in just a moment. We'll talk about it. Input endorsers. We intend on using Mithril for voting, and we intend on using Mithril for other applications that come up in that many to one concept. Okay.
미스릴 기술에 대해 더 자세하게 알고 싶으시다면 코리아풀 비디오를 참고하시길 바라겠습니다. 미스릴에 이어서 많은 분들이 기대하고 있는 히드라에 대해서도 알아보겠습니다.
Okay. Then we have Hydra, and Hydra is also fast evolving. And version 1 is another one of those Q4, Q1 situations. And these are public roadmaps. You can actually go to GitHub and look at the repos for them, and you can actually see the roadmaps real time. And they're on different release cycles. I think it's 3 weeks here for the release cycles. It's a very agile project. 2 weeks here for Mithril. Nice proof of concepts as they go through. And basically, Hydra, a lot of people think that Hydra is kind of like this because there's conversations about it, that Hydra is like this overlay network that's going to sit on top that the SPOs run, and they run all these heads, and the heads communicate with each other, and somehow it's some sort of accelerator network. You could certainly imagine a world where that's the case, and for things like microtransactions, that would make a lot of sense. But the current version of Hydra that's under construction is more like basically a dApp embedded software. So the way that we design Plutus is that you have an on-chain component, and that's your Plutus script. And then you have this idea of off-chain infrastructure that coordinates with the dApp to run things. And this is very common in the Ethereum model as well. And they have all these things to combine these two. And that off-chain infrastructure, sometimes it's centralized, sometimes it's not centralized. It depends on the specific dApp. The idea of Hydra is that it would be part of that off-chain kit. So it would be embedded dApps that require a lot of scale. And basically, it would do something similar to what's occurring with Mithril, where you go many to one or some. So you can imagine a lot of use cases, again, like voting, like DEXs, things for payments, et cetera, where you want to batch a lot of stuff together, and you use Plutus scripts on chain sparingly. So you only have a few, and then you do a lot of stuff off chain. That is kind of what the version 1 of Hydra is looking at. Having this acceleration network that runs off chain for super high throughput for lots of transactions, it seems like it would be a super useful, super nice thing to have, similar to like a Lightning network or something like that. And we are exploring it. There's something called the Hydra Tail protocol. But the reality is that if you want to achieve in next year and the year after high throughput, you're really thinking about the whole banana, the whole architecture. So you're thinking about the design of Plutus itself and how that off-chain and on-chain communication works. You're thinking a lot about the extended UTXO model and how to most efficiently use it. But then you're also thinking about having specific off-chain infrastructure that can work on-chain. It has an on-chain representation, in this case, a Hydra head. And by embedding that inside the dApp, then basically you can take lots of stuff and you can make it one thing. Okay, so what does that mean? It means your cost goes down, your operating cost, your op cost, and that means your speed effectively goes up because these can be run with high efficiency infrastructure. They can do tons of things, lots of TPS, and you also can federate them as well. So this is kind of the design goal of version 1. And there's already several dApp developers in the Cardano ecosystem working directly with the Hydra team. And actually, some of them have started making open source commitments to it. Obsidian is one. And so that's really exciting. And they've made some commits to Hydra. So Hydra is becoming rapidly a full open source program. And what's cool about it is that everybody has an incentive to add to it, because as they embed it in the guts of their application, then basically the future versions will be done by not just the Cardano core team, so the foundation and IO and others, but actually by the community as well. And the goal is to reduce your operational cost and improve your transaction throughput and speed. Mithril is also closely related to Hydra in that components of Mithril could connect to and work with Hydra, which is why they have shared teams. So as Mithril advances, Hydra advances, these two things are actually going to be massive for improving scalability. Now,
히드라 기술에 대해 더 자세하게 알고 싶으시다면 코리아풀 비디오를 참고하시길 바라겠습니다. 입력보증자에 대해서도 알아보며 입력보증자에서 미스릴이 어떻게 활용되는지, 그리고 탈중앙화 가버넌스가 왜 필요한지 알아보겠습니다.
Now, the biggest single contributor to our ability to have throughput will be input endorsers. And I don't think input endorsers are necessary in 2023, because if you just look at improvements to diffusion pipelining and what we're doing with Plutus, as well as Mithril and Hydra, the reality is we'll have more throughput than we'll have use, because the effective TPS rate is quite high already. You know, again, cryptocurrency Reddit, they just have an incredibly naive, stupid way of doing things. And so they say, oh, you're 9 TPS, but the real impact is in the dozens or hundreds of TPS when you actually look at the blocks and how people are using the scripts and how things can be chained together. So input endorsers, what we're doing right now is we're writing the SIPs for them. So we had a humongous design process. It started in January of this year and all the way to last month in September. In California, we had a huge workshop with all of the researchers. And in June, we had a big thing in Edinburgh with all of the researchers. And basically, this allowed us to get the design figured out. So now Ben Beckman, the head of architecture at IO, Ben, what he's working on is actually translating this end result into SIPs. And there's a lot of simulation that's going on. So input endorsers are not a small thing. They're actually a complete reimagining of the blockchain structure. Okay, So what happens is that you go from this standard process of a chain of blocks, and there's only one canonical view, to basically doing a lot of these things asynchronously and in parallel, and they just kind of get batched together. And then asynchronously and in parallel, lots of stuff happens, and then they get batched together. So this concept of input blocks and key blocks, as discussed in our parallel chains paper. Now, this batching, you think of mithril certificates where you talk about batching transactions, events together. You also could reuse this technology in the extended UTXO model to batch blocks together. So it gives you a way of figuring out conflict-free history. And potentially what this means is that you have asynchronous parallel processing of an enormous amount of events. So the throughput gains, assuming new data structures and assuming new designs, are gargantuan for this, because you basically can be real-time continuously running computations. Right now in the current design, only 0.25% of your block time budget is for computation. So running execution of scripts. So that's incredibly limiting. 0.25%, not 25%, but 0.25% of your block time is for script execution. So it's a very scarce resource. Here, it's asynchronous, so it's continuous execution. So we expect to see not just a 10x, but a very, 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 very significant increase in speed and a reduction in cost. That's what we're looking for. Now, what's really cool about input endorsers as well is how do you do this where the network doesn't stall, Solana style? Okay. And then the other thing is, do you preserve or reduce decentralization? So one of the key metrics that we have with writing these SIPs is a model where your set of SPOs increases, meaning you actually have a larger K, despite the fact that you move to continuous execution of scripts, much higher throughput of transactions, and a completely different structure. Now, Mithril is essential for this because as you get here and you talk about that kind of throughput, your blockchain is going to grow. The amount of shit that's going on is going to grow considerably. So if you want to do a bootstrap, you need to have an accelerated bootstrap mechanism. So fast bootstrap and better support for light clients. So the Mithril program will continue all throughout 2023. Ton of things are going to happen. The Hydra program will continue all throughout 2023. Tons of things need to happen. We need to keep pushing forward on that because these are components, if you think about how they get structured together, into how one would approach building out input endorsers. Now, input endorsers aren't the only part of the story. Their design we consider to be, so the SIPs we consider to be the final milestone of Basho. Because if you think about it, all the stuff up here is effectively enough for Cardano to be competitive against all the top 15 cryptocurrencies, including Solana, that are in circulation. When we look at what's happening with input endorsers, this evolution combined with the other open source programs basically is something that will allow Cardano to scale over the next 5 to 10 years of use. Voltaire is required in order for input endorsers' final design to be ratified because it's going to change the logic for SPOs. We would argue for the better. It's also potentially going to introduce new reward mechanisms. So the reward functions need to be adjusted as well. It's going to change how staking works a little bit, these types of things. And there needs to be some competition in the ideas. Like, for example, DC Spark has expressed some interest in examining the SIPs for it. So there needs to be a long community review because it's such a huge component. And the question is, how do you avoid network stalls? How do you ensure further decentralization of the system? How does the system be more fair to SPOs and do good things for them? And then also, how do we reuse and leverage existing technologies like Mithril, for example, and Hydra, for example? So this is all a big, big part of the Basho agenda.
입력보증자 기술에 대해 더 자세하게 알고 싶으시다면 코리아풀 비디오를 참고하시길 바라겠습니다. 마지막으로 사이드 체인에 대해서도 알아보겠습니다.
The last thing is side chains. And the idea here is that you use Ouroboros to bootstrap a sidechain. So that sidechain will take from Ouroboros some set K of SPOs, and that becomes the quorum with a BFT protocol of the sidechain. And there's also a bridge to move value back and forth. Oh, by the way, this also is talking about Babel fees and tiered pricing as well. So there's a huge reset of the pricing and fee model as well with input endorsers. So anyway, so there's a bridge component, and then there's a BFT component. And so you have your main chain, and then you'll have this ecosystem of side chains. So why? Well, because side chains are going to have their own business logic, their own application domain, and that's a lot of TX volume. If that TX volume is being held by a side chain, then all of these things are being done in parallel, meaning that the processing of those side chains doesn't reconcile on the main chain, so it doesn't consume the resources of the main chain things. Now, what's really cool about sidechains and Cardano is if you hold ADA, okay, right now you get staking rewards with ADA. Okay, well, these SPOs that are selected to be part of a subset, well, they're doing work, and you're partnered when you're staking with people. When you delegate, when you set up a stake pool, you get compensated if you do work. So if they're maintaining the state of these systems, they actually pay a reward for that work that's being done. Well, that reward would then go to the SPO via their fees, but also the people who have delegated. So when sidechains are implemented in the future, your staking rewards will go from just ADA to all the coins that those SPOs have contributed to and made blocks in. So you'll actually get a flow of these. So there does need to be a little bit more work on how to set that up.
앞으로 카르다노 확장성을 위해 미스릴, 히드라, 그리고 사이드 체인이 개발되고 이 기술들을 활용해 최종적으로 입력 보증자를 통해 미래의 확장성까지 고려하는 모습을 보면 찰스는 이미 10년 또는 수십 년 미래의 카르다노를 이미 그림 그려놓지 않았을까 싶습니다. 11월에 있을 카르다노 서밋에서 더 자세히 설명한다고 하니 어떤 큰 그림을 그리고 있을지 기대가 됩니다. 오늘 영상이 도움되셨다면 한국인들을 위해 최저 수수료로 운영되고 있는 코리아풀 스테이킹 풀의 에이다를 위임하셔서 많은 응원 부탁드리겠습니다. 지금까지 카르다노와 한국인들을 이어준 다리 코리아풀이었습니다. 시청해주셔서 감사합니다.